So let us now discuss this steady speed and changing velocity. So what is the steady speed? Steady speed means constant speed, means speed is not changing, no changing speed, constant speed. But this is a steady speed and changing velocity, means together. So first of all, you know that velocity is a vector. So since velocity is a vector, so it's a combination of its magnitude that also is called speed of that velocity plus direction. Now the question is coming on changing velocity, means velocity is changing. So you do the permutation and combination with this magnitude, means speed and direction, and can see how many, by how many ways the velocity will change. So first case, magnitude, that is speed, constant, but direction changing. But direction is changing. So this is, you can say the velocity is changing. That is first case. Second case, the magnitude, that is the speed, changing, but direction is constant, means not changing. Third case is magnitude is changing and direction also changing. So in all these three cases, the velocity is changing. But we had to study about steady speed and changing velocity, means we have to look for a situation or study a motion where the speed is constant but its velocity is changing, means your speed is constant but velocity is changing. For the velocity to change, if speed is constant, direction must change. So number one case, and this is being talked in reference to the circular motion. So uniform circular motion is a case where the speed at each and every point on the circle of the moving particle remains the same, but because it is moving in curved path, its direction is changing. So that is what it referring to, changing velocity. So particle moving in this circular path at any point on the circular path, if you want to show the velocity of the particle, means instantaneous velocity at that instant. If you want to show, what you do, you draw a perpendicular to the line which is drawn from the center of the circle to that point. So this is your 90 degree, this angle is your 90 degree, and this angle is your 90 degree. So for a uniform circular motion, if you want to know the velocity at this instant, if we say at A, this point B, this point C, so VA, if you want to know, you will have to draw the line, straight line from the center of the circle to this point A, and on that you draw a perpendicular in the direction of the motion. So we can write here VA, here it is VB, here it is VC. So if it is a steady speed but changing velocity case, then the magnitude of VA should be equal to magnitude of VB equal to magnitude of VC. It should fulfill this condition, and let us give it a name as V. So for uniform circular motion, magnitude of VA should be V, VB should be V. So then you can say that it is a uniform circular motion. It means the speed is steady but the velocity is changing. Since we are studying right now about the circular motion, so we have taken this example that the particle is, or the body is, moving in the circular path. But there can be other cases also where you can keep your speed fixed, but the direction continuous change. Like if you are going on a, if you are driving a car on a serpentine road, you can keep your speed fixed, but at each and every point, the direction of the velocity is changing. But our focus is now on circular motion only. So let us do a question on it that is given in your book. 3. Explain why all the velocity arrows in figure 16.5 are drawn the same length. This is your figure 16.5. It is saying why this, this and this length is same. So you can say the length is same means speed at A is equal to speed of B at B is equal to speed at C, because you know in a vector the length of the vector represents the magnitude of that vector. So here it is VA, here it is VB, here it is VC. These are the velocity. At that instant when the particle was at A, it is having a velocity VA. When the particle is at D, it is having a velocity VB. When the particle is at C, it is having a velocity Vc. But the magnitude of all these three is equal to V. That is why the length has been shown equal. So your interpretation should be, since the length of these velocity vectors are same, and from the vector definition we know, so when we are representing it on paper, the length of that vector representing the magnitude of that vector. So it means magnitude of velocity at this location, A point, B point and C point is same, is equal. So it is a uniform circular motion. Means steady speed but changing velocity. Velocity why changing? Because the direction is different. Here the velocity vector is pointing in this direction. Here the velocity vector is pointing in this direction. And at C velocity vector is pointing in this direction. So this was your third number 3 questions, right? Now second question is, a toy train travels at a steady speed of 0.2 meter per second around a circular track as shown in figure 16.6. So this is your figure 16.6. This is train. The train is moving in this direction like this. It is moving on the circular track like this. And it is moving with a steady speed. Means again it is a uniform circular motion, right? And A and B are 2 points opposite to one another on the track. A and B is exactly opposite to each other. Means the line which we draw is passing through the center of this circular track. If we take our axis downward as y-axis and associate a unit vector j in this direction, so what you will write for the velocity vector at A? The magnitude, let us say this is, we are writing as V. So VA will be V into unit vector in the y direction. VB will be V into unit vector in the negative of the y direction, because here it is, the direction is opposite to this y axis. in part A, what is it asking? Determine the change in the speed of the train as it travels from A to B. So mathematically, change in speed is written like this. So it will be VB minus VA. Means speed at B minus speed at A. But what was the speed at B? 0.2 meter per second. What was the speed at A? 0.2 meter per second. So this will be 0. So this will be your answer for part A. Now let us attack on part B. It is asking change in the velocity of the train as it moves from A to B. So change in velocity, how will you write mathematically? Since velocity is a vector, we will write like this. So velocity vector at B minus velocity vector at A. V minus J V J minus V J minus V J. The change in velocity will be minus 2V J cap. So J cap is minus means in towards the negative of the y axis. So y axis positive is downward, so it is upward. So change in velocity from A to B is 2 times V into J. And what is V? V is your 0.2. So you can write 0.2, so it will become 0.4 J meter per second. Don't forget to write the unit. So this J is telling your direction, 0.4 is telling your magnitude. Magnitude is always positive, so it means J is minus J. So J you can shift over here. Minus J cap is towards the negative of the y-axis, means in this direction. The change in velocity, the direction is this way, and magnitude is 0.4. So this will be your complete answer because it is asking change in the velocity. Sorry, change in the velocity. So velocity is a vector, means you have to give the magnitude as well as the direction. I'm not sure whether you are given such kind of question also in your exam, but just for your understanding. They give only this diagram, nothing else. And they may ask you like, what kind of motion is this? So you can take use of your ruler and measure the length of this vector. If the length of this vector, suppose this is your, let us define this as point A, B, C. So at A, this velocity vector A length is LA. At B, it is LB. At C, it is LC after measuring with the ruler. And you got this, that all length LA is equal to LB and is equal to LC. So then you can say that it is a uniform circular motion. In this case, it is if LA is equal to not LB, not LC, maybe LC equal. So even one point it is not equal, then you can say it is a non-uniform circular motion. Non-uniform So this is just for your understanding, for concept clarity. Like if it is being given like this and no other information, then you can check with the ruler and can say what kind of motion is this. Is it uniform circular motion or non-uniform circular motion? So hopefully the things are clear. Next part we will go on angular speed. To avoid the video being long, I'm just stopping it here.